All right, now let's stare at part B. So we have r equals 4 sine 3 theta, and we're looking for the area of two paddles, okay? So why don't you go ahead and use your TI-84 to get a visual for r equals 4 sine 3 theta and see what it looks like. But we have to approach it in a very educated way to be able to pinpoint what the alpha and beta in the area formula R so that we can actually check how the area is swept through the rays theta equals alpha and theta equals beta. Okay, so if you are ready to graph it, and you should be able to expect this kind of graph, R equals 4 sine 3 theta. Okay, so we are asked to find only two of them, the area of two of them. And then these are symmetrical. In fact, if you find one of them and multiply by 2, that should be perfectly fine because this graph is very symmetrical in terms of the paddles. Okay, so if I find, let's say, the area here, uh, and I can multiply it by 2, and we're completely done with that. All right, so let's check. Um, First of all, let's have a little table here just for our reality check, okay? Let's look at certain theta values and R values for that. I want to do it in front of you. I could just put a table of values, but I just wanted to do it with you so that you can experience all parts of labeling this graph, okay? So when theta equals 0, you are looking at 4 times sine 3 times 0, which is sine 0. So this is 0. So that means that I'm starting right here, okay? And then let's go to theta equals, let's see, pi over, I'm going to go with like pi over 12, okay? Pi over 12 is even right here, okay? So if you want to have a ray over there, so this is pi over 12, okay? And I want to get this point, obviously. So what is that point exactly? This is 4 times. 4 times, go ahead and punch in 4 times sine, 3 times pi over 12. That's pi over 4. Okay. And sine pi over 4, going back to my unit circle here, sine pi over 4 is the y-coordinate of the point. Here we go, y-coordinate of the point. So that's radical 2 over 2. Okay. So let's go back here. So this is 4 radical 2 over 2. That's 2 radical 2. I just leave it with the exact numbers as is, okay? How about pi over 6? At pi over 6, I think we're going to make a peak here because this is your, let me just erase this. This is your pi over 6. Okay, so pi over 6 takes you to 4 sine pi over 2. Okay, and I can use my unit circle, or you use your calculator if you want to, but I want the exact numbers. Okay, at pi over 2, the y-coordinate is 1 on the unit circle. Okay, so that's exactly what I'm looking for. Okay, so you can go back. You can go back here. I'm sorry. You can go back here and write that this is equal to 4. Okay, that means you're walking like 4 units on this graph. Okay. All right. So that means now I'm going in this direction. In this direction. So I got this part swept all the way. I got this part swept all the way. Because when I change my array from theta equals 0 to theta equals pi over 6, so this is pi over 6, right? Pi over 6, right? So pi over 8 is right here, okay? So that's a different one. So from 0 to pi over 6, I get the half of the paddle covered, okay? So that means if I keep moving here, let's say like I keep going to pi over, let's see, pi over 3. Pi over 6 is like 30 degrees. Pi over 3 is 60 degrees. So the corresponding r for that is going to be 4 times sine, let's see, pi over 2. Maybe we should get an in-between angle one more. So one more in-between angle, okay? So I have pi over 4 here. Pi over 4 is right here, okay? So for pi over 4, it's 4 times sine 3 pi over 4, okay? Let's just go ahead and check sine of 3 pi over 4. So it's radical 2 over 2, okay? So going back here, so this should be pi over 4 should take you to 2 radical 2, okay? So essentially you are right here, okay? You're still going in this direction, okay? And pi over 3, and pi over 3 eventually taking you to sine pi, okay? So 3 pi over 3, essentially that's pi. And sine pi is supposed to be 0 because that's the y-coordinate of pi. That's exactly equal to 0, okay? So we're back to 0. We're back to 0. So one paddle is covered all the way in between the rays. Theta equals 0, which is this one, okay? Theta equals 0. And theta equals, let me just write here, pi over 3, okay? So once you sweep theta equals 0 ray all the way to pi over 3, one paddle is sort of like covered, all right? So what I can do here, I can cheat here, and I can just like find the area of one paddle and multiply it by 2, okay? All right, so let's go back. And if you want to, by the way, find the other paddle and what the theta corresponds to that, you have to keep moving in this direction. Okay, you have to keep moving and see where the second paddle is covered. Okay, so I won't do that, but I'm going to cheat here. So I'm going to find the area of this paddle, which is, I know that thetas are in between 0 and pi over 3 all the way to have that area covered. So I'm going to go back here and then write that the area of two paddles is equal to 2 times the formula, right? 1/2, 2 times 1/2, integral from 0 to pi over 3, okay? Integral from 0 to pi over 3, and 4 sine 3 theta squared d theta. I'm using the area formula that I showed you in the beginning, okay? So let's see what it boils down to. So 2 times pi over 3, 2 times 1/2 is 1. So this is 16 sine squared 3 theta d theta, okay? And now you can go ahead, and if you want to, you can just do the indefinite integral first somewhere on a scratch paper. Let me just do it right here, maybe. Okay, so we are trying to find the integral of sine squared 3 theta d theta, and this is another instance that you're using the power reducing formula, because we have sine raised to the power of 2. That's an even power of sine. So let's use power reducing formulas for sine, and that takes you to 1 minus cosine 6 theta divided by 2 d theta, okay? And that is integrated as theta minus 1/6 sine 6 theta plus c, okay? So once you have this, you can go back and use the fundamental theorem of calculus, without c obviously for the antiderivative. So theta minus 1/6 sine 6 theta from we also have 16, by the way, don't forget that, okay? From 0 to pi over 3, okay? So while I erase this part, you can work through evaluating the antiderivative at the upper and lower limits. So here we go. So this is 8 pi over 3 minus 1/6 sine 6 times pi over 3, that's 2 pi, okay? Minus 8 0 minus 1/6 sine 0. Okay. Well, this term is going to be 0. This is already 0, and sine 2 pi is already 0. You can use your calculator or go back to the unit circle. Essentially, it's 0 and 2 pi. 0 here, 0, and 2 pi is the same as 0. Theta equals 0, right? So the sine is the y coordinate. So here we go. We have that equal to 0. Okay. So let's go back to where we are here. So we have 8 pi over 3. Okay. Okay. Again, I cheated here by just finding the area of one paddle and multiplying by 2. But if you want to get 2 paddles, I can tell you that you can continue up to 2 pi over 3 here, and you get the other paddle covered. Okay, so and that way, I think it's this paddle. Okay, because you start from pi over 3 going all the way to 2 pi over 3, and you are going to have like negative r values, so that's going to cover this paddle here. So because the question says like any 2 paddles, the area of the any 2 paddles, here we go. So if you integrate here from 0 to 2 pi over 3, okay, 0 to 2 pi over 3 without multiplying by 2. So what I'm trying to say is that this 2 is gone, but you put 2 pi over 3 here, okay? So then you have the area of 2 paddles covered, and then you will still have the 8 pi over 3 as a result of this integral. And then you can go ahead and please do it after you finish this video just to convince yourself, all right? This is already a long video, and I'm going to do part C in the next video. I'll see you there. Bye.